Hello and welcome back. This topic is going to be actually a really interesting topic. This topic is known as recursion. Now, before we jump into any code, it's kind of nice to be able to think about a metaphor or like an analogy for this topic, just because it can be conceptually quite abstract. So I want you to imagine for a second that you are hopping into the shower to wash your hair, and you read the bottle of shampoo, and on the bottle it says lather, rinse, and repeat. So you get into the shower and your current hair state is dirty. And so you give a quick lather with the shampoo, you wash it all up, right? And you rinse it out. And now your hair is a little bit cleaner, but it's not as clean as you want it to be. So you do it again. You lather, you rinse, and then you check your hair again. And it's a little bit cleaner still, but not all the way clean. So let's say you do it one more time. Lather, you rinse, and now you recognize your hair has reached the level of cleanness that you were, or cleanliness that you were hoping for, and so you stop. And this actually is the idea of recursion. The shampoo bottle effectively tells you to restart the process. It calls on itself, because it is the shampoo bottle saying, use me, use me, use me, until we reach the desired level of cleanliness. And the desired level of cleanliness property is actually our problem space getting smaller and smaller and smaller until it disappears, until we now have clean hair and we can stop the process. Let's draw this up with an example. Let's call a method say hello, and we want to say hello 4 times. Public static void say hello, and this is how many times we're going to say hello. Let's go ahead and do this in a for loop to start. Oops, I equals 0. I is less than the number of times we want to say hello, I plus plus, and let's go ahead and say hello that many times. Hello. Okay, and we will put some, there we go, some brackets in there. And we are ready. Oops. Let's just visualize this. This is old news for us at this point. It is literally just a for loop that each time I increases over here, as we can see, and hello prints out. Once I reaches 4, it is no longer going to be less than num times, because num times is 4. They're equal, right? And so we break out of our loop because this came back as false. It's really important that we do understand that what actually happened here was after that 4th print, when I was equal to 3, I did increase to 4 because of the I plus plus. And then the I less than num times was checked and it became false, and then we jumped out of the loop at that point. So understanding that is actually going to be really important here. But what we can see is we had that main call, which occurred right here, and then we did our say hello method, and this ran 4 times. Once this method ends right here on line 10, we come right back up where we left off, and we will continue on line 4. That's all really important for us to understand so that we can now look at what's going to happen when we do this recursively. When we write recursive code, we need what are called a base case and a recursive case. These are our 2 different cases. Sometimes the highlighting here is a little bit weird. I can do that because it pretends for some reason that only Java or that only Python comments would work. Sorry about that. Now, our base case is basically the situation in which our code needs to stop running. And our code is passing in a 4. That means that, and we know that that means we want it to run 4 times. So we want it to run when 1, 2, 3, or 4. So if our value is a 1 or a 2 or a 3 or a 4, we're going to want to run our code. Otherwise, we don't want to run it. So there are different ways to set up our base case and our recursive case. But most frequently, we want to set up our base case first. Just seems easier a lot of the time. So we need to understand that since we are passing in the total number of times, it's actually kind of like I starting that num times, going greater than 0. Whoops, that's supposed to be a greater than sign, sorry. And then going down by 1 each time. So all I've done is reverse our loop. It actually is still doing the exact same thing. So now I can use my base case directly from here. I could just say, well, I is not equal to 0, I guess, because it's coming in as 4. I want to print out this word. Oh, wait, no, when it is equal to 0, that's when we want to stop. Do nothing. We have hit 0 and want to stop the code. Perfect. Whoops. And for all other situations, we have our recursive case, else, our recursive case. And what do we want to do in our recursive case? Well, we want to print hello, that's for sure. And then what we want to do is we want to do just what the shampoo bottle does. The shampoo bottle said repeat. So odd that this is struggling with the indentation. Okay, what does our repeat look like here? Well, we're going to say hello. We're going to call ourselves just like the shampoo bottle said go back and use the shampoo bottle again. We're saying use the say hello method again, but num times needs to change. Well, our loop before, once I reversed it, was going down by 1. So here, num times needs to go down by 1. If this is confusing to you, let's just take a quick look at the visualization, and I'm hoping it will help. So first things first, we do come into this method just as we did before. Previously, we ended up with an I variable. Here, we're not going to actually have access to an I variable. What we're going to do is we're going to print hello, and watch what's about to happen right over here on our frame. We're about to call say hello again, but with num times. Previously, this method ran 4 times, right? Or the method rather went into the method once, ran the for loop 4 times, and then we exited our program. Now we're going to call the method again. So our call stack is actually growing. Now we call it with num times equals 3. If num times does not equal or is equal to 0, we're going to stop. But it's not 0. Num times is 3. So we're going to print hello again. And then look at this. We have to actually call num times again. There we go. We're adding to our call stack each time. We'll add to our call stack again. Print out our last one, add to our call stack again, and check this out. Num times is now equal to 0. If num times equals 0, we go into here. When we go into here, we're not going to add another method call to the call stack. Therefore, our method will actually end. And when a method ends, it gets pulled off the call stack. And now we can go and pick back up from the last call we made, which is this one right here, line 16 of our call stack. This also is now going to end this method, which means we're going to take this off the call stack and go back up again. Sometimes I refer to the call stack a little bit like a stack of pancakes. You can imagine a stack of pancakes as if you were trying to eat pancakes while the chef was cooking them. You're sitting there eating a pancake, and if the chef puts the pancake on top of the one you're eating, you actually have to stop eating that one and start eating the one that's on top. And we keep stacking pancakes on top of each other, and you cannot finish eating the ones below until the ones on top are completed. Running line 16, the closing of this method, is like finishing eating a pancake. So while the chef was still creating pancakes, placing them on top, we may have started eating the previous pancakes, being these method calls, but we never actually finished eating them. We never managed to reach the end of the pancake or that line 16 closing bracket to our method. Now that the chef is no longer creating those pancakes, that's what that if statement was. The do nothing is our base case. It's the chef stopping the pancake train. We're now able to go and actually eat our way through each of these pancakes all the way back up until our program, ends, and we have all 4 of our hellos printing out. We have our base case and our recursive case in this way. Now, it's worth noting that having a do nothing if statement is always a really bad idea. I don't like that. So there are things that we can do. We can say if num times is greater than 0, make a recursive case, else make a base case, where these 2 lines then move up here, and this could move right here. So this will ensure that when num times is 4, it prints hello. When num times is 3, it prints hello. When num times is 2, it prints hello. When num times is 1, There we go. When num times is 1, this will be false. It will come here and print hello. We've now said print hello 4 times, but we only need to call the recursiveness of it 3 times. Let's take a quick look and make sure that that runs exactly the same. And now we don't have any empty statements. We can print hello and go to 3. Print hello and go to 2. Print hello and go to 1. 1 is not greater than 1. It is equal to 1. We will go into our base case. Our base case is the else. All we do is print hello here. And now we can finish eating each of those pancakes, pull them off the stack, and our code completes. This can be written one additional way. For example, we could have just done something like if num times is greater than 0, we're going to run for 4, 3, 2, and 1, and then when it's equal to 0, we stop. This also works. I have now removed having a base case and a recursive case, and I've sort of just collected it all into one if statement. You don't have to have a base case and a recursive case, as long as you have a way to recurse and a way to stop. And if one if statement can take care of that, then that's totally fine. We can see that this goes through, does all of our prints. Now num times is 0. Since it's 0, we just don't go into this if statement, so no print occurs, and our code ends all the same. Now we can see that this is basically the same thing as a for loop, so it really doesn't help us that much. And in future videos, I'll show you when this becomes actually very helpful. But in reality, there actually are some problems that are naturally recursive. For example, if we wanted to do a summation, we'd want to do something like this. Whoops, sorry. Sum up 0 plus 1 plus 2 plus 3 plus 4 plus 5. That's what a summation is. So if I tell you I want to sum up all the numbers between 0 and 5 or 1 and 5, because adding 0 does nothing, we could understand why something like this might be really, really helpful. If we pass in the number of times, what should happen in this scenario is we actually want to return our summation. So let's have a sum that comes out up here, system.out.println the sum. It's always nice to start with writing this in a for loop if you're ever unsure of what to do. So I'm actually going to do that here. We start our for loop off with int sum equaling 0. And then we can say for int I is equal to, we can start at 0, we can start at 1. Thankfully for summations, it doesn't make a difference. I is less than or equal to num times. Since in this scenario, we do want to include 5 for, or whatever value comes in as part of our summation. I plus plus, and what do? We just add up each value of I into our sum and return it. I will very quickly just jump to the end of this execution to ensure that this works the way that we're intending and that we get 15 out of it. You're welcome to pause the video, type out this code, and walk through it in Python Tutor if you want to see how that for loop actually worked. But we can see that it did indeed work. Now, if we want to switch this into a recursive method instead, there's a few things that we can look for in order to do this. I'm going to go ahead and comment out our situation here. There we go. Okay, how are we going to do this differently? Well, for all this time we've told you you can have multiple return statements. This is going to be the first situation where you are allowed multiple return statements. Just because I'm allowing it now doesn't mean it's allowed all the time. 2 return statements in a recursive method is perfectly reasonable. More than that is unnecessary, and you should be using a variable. It just often helps with the conceptual understanding of what the heck is going on here. Now, we want to start with our base case. And our base case, as we know from before, we can't use a base case of num times because that's the value that's coming in. But we can use a base case of this as a stopping point, just as we did previously. So if num times is 0, what do we want to do? Well, let's ask ourselves, what would we have returned if summation had just been straight up 0? Well, we would have returned 0. So let's go ahead and return 0. Perfect. Else, we have our recursive case. And what is our recursive case? It probably will help us to do this in 2 steps. I will put an int sum over here. My int sum needs to be equal to, well, each of these rounds adds 1 to our total. So we need to add 1, and we're going to need to add the number of we need to add the next value, right? Really is what it is. We need to add the next call, the next call. In our for loop, we were adding the next call. Oh, it doesn't add sum, it adds num times. First it adds 5, then it added 4, then it added 3, then it added 2, then it added 1, then it added technically 0. We'll do the same thing here. So we're going to take our num times, which will first come in as 5, and then we need to add 4. How are we going to add 4? Well, we need to call summation again and decrease num times. Once we've done that, we can return our, sum. This looks really confusing, so running it is going to be really important for us to understand what is going on here. Python Tutor won't let you run recursion functions too deep. So 5 is pretty reasonable, but anything deeper than that starts to get tricky in Python Tutor. So we can see we call it with num times being 5, which means we're going to go into the else. We're going to end up with this sum variable. Sum equals num times plus the summation minus 1. Now remember, anytime that we call a method, we end up going further down in our stack. It's like adding a pancake to our plate of pancakes. So our code actually stops running for a minute. At that line 17, it stopped there, and we recall the summation method, only now with num times minus 1. And this is going to happen over and over and over again until num times is 0, at which point we come in here and we return 0. This return 0 is going to replace this call right here on this line in this call method from this pancake right here. It's just like a little bit of syrup dripping from this pancake to this pancake. It can't drip all the way down. This pancake is in the way. So let's go ahead and run this. Since our num times is now 0, we're going to return 0, and that return value only goes up 1 level. 0 gets placed right here. Num times on this level, as we can see, was 1. So now we can sum 1 plus 0, and that's how we got a sum of 1. Now we have another return value, only this time it's 1, and it's going to return back up to here. Back up to here on line 17, we'll now take 2 plus our return value of 1, totaling 3. And now our sum is 3. And this will continue to happen. Next, it will be our num times plus our summation. Our summation at that point is returned as 3. So 3 plus 3 will return us a 6. We will continue with that, a return value with 10. And then our final return value will take the summation that's coming from here, which is 10. And it will add it to num times, which is 5. We will get a sum of 5. This is going to now return the sum of 5 up again. Sorry, the sum of 15 up again. It's going to return it back up to main, where sum at main is now 15, and we can actually print out our sum. And there we go. So we can actually see that a summing problem works really well, since what we're trying to do is add every single number. If you've done any kind of calculus class yet at this point, any kind of, maybe not a calculus class, but maybe a discrete math class where you've done any kinds of proof by induction, this is very similar to that situation where we need to sort of have our base case and recognize that we're able to trust the problem space will work for each subsequent value. So here we show that it works for 1 value and then minus 1 value. And then we need to trust that it's going to work all the way down to our base case. And that's exactly what just happened. Now, this is just an introduction to recursion. We'll go deeper in future videos, but I would like us to take 1 minute to just see what might happen if we forget a base case. It might not work in here because it's Python Tutor actually. So I'm going to pick this up and we're going to move it over, over here for just a minute, just because I don't think that Python Tutor actually can handle what would really happen. Let's just get all of this set up correctly so we can read it nicely. We've now removed our base case. No base case. So what the heck is going to happen to our code? Well, let's take a look. CD documents. Nope, that's not where it is. Desktop. Let's run this code. Oh, I have two main methods. Doesn't love that. That seems pretty reasonable. Those are lined up. Okay. Whoops. Let's try again. Do I have an extra bracket? Oh my God. Sorry, everyone. There we go. Third time's a charm. It runs. And now let's see what happens. And what ends up happening is we actually end up tipping over our plate of pancakes. The chef never knew when to stop making pancakes, and they just kept making them and making them and making them and making them and making them until, just go all the way back up, it overflowed. This is called a stack overflow error. With that, we can now write recursive methods. We understand that it is a method that calls itself. The method should have the indication of a stop and start case, often known as, or a stop and continue case, often known as a base case and a recursive case. Sometimes that looks like an if else. Sometimes it looks like just an if with extra returns maybe around it. We really want to avoid those empty ifs or empty elses. So we want to make sure we're writing our code in a smart way. In our next video, we're going to look at a few classic examples of recursive problems, how we break them down, and how we solve them. Thanks, everyone, and I'll see you in the next video.